Hello everyone, Grzegorz Baran here. In this video I'm going to show you the result of single image based reconstruction with the Alchemist when processed on a few totally different types of surfaces. In details I'm going to show you how I capture 9 surfaces used to build 9 PBR materials. Next, I'm going to tweak each with the photoediting software to remove geometry distortion and calibrate the color. After that, I'm going to process tweaked images with the Substance Alchemist to generate set of fully functional PBR materials. To finally compare all those materials together to see where exactly single image-based reconstruction makes sense and where it is not the best choice. As every image differs, extracting full set of PBR data from a single image is a quite tricky process and more or less it's just a guess. To create a functional PBR material from a single image, a single image-based reconstruction algorithm has to interpret the surface and extract the color, light and height information from it. Since the only source of data for reconstruction is a single image, it benefits from any human input given as a direction and interpretation during the reconstruction process. But no matter how good the software is and how accurate is the human input, we can do only as good is the source image. And this is why we need to make sure that what we capture is consistent, free of any noise and glitches, and is as high quality as possible. I capture a few different surface types in slightly different lighting conditions. For every capture where it was possible, I was trying to include a color and scale reference. For scale reference, I usually use 2 folded rulers. Since I was aiming to cover 180 by 180 centimeters, I unfolded both rulers just to cover 180 centimeters and set them in 90-degree angle to each other. Unfortunately, for some surfaces, using rulers as a scale reference or color checker in the same image is impossible. In this case, I captured the color checker as separate image as well as myself next to the object to get the sense of scale. The first surface I captured was a reinforced concrete used to handle a naval gun. I captured it with the drone. It is flat and consistent surface. During the capture it was slightly illuminated by the sun, but without any strong direct shadows. Due to the strong wind pushing the drone, it was quite hard to take a sharp image and frame it with the both rulers efficiently aligned along the frame borders. So to shorten the exposure time, I set up the aperture to 3.5. To make sure I have it covered, I took a few images and this is the one I'm going to use for reconstruction. As you can see, the Mavic 2 Pro camera has terrible barrel distortion, which has to be fixed in photoediting software later. The next surface I captured was the low grass. To capture it, I also decided to use the drone. Same as before, I included the color checker and rulers as color and scale reference. Since the drone generates the wind beneath, using it to capture a grass surface can be quite tricky, and if the grass would be higher, I would use a DSLR camera instead. But since it was a short low grass and I hovered over 2 meters above the ground, it was fine. To make sure the exposure time is really short, I set up the aperture to 2.8 and took a few pictures. The drone would be a big problem for the next surface, as leaves are very vulnerable for any form of wind. This is why I decided to use a DSLR camera mounted on a fully extended monopod. Same as before, I used folded rulers as a scale reference and the color checker as a color reference. Because it is very hard to hold the camera steady on extended monopod and get sharp images, I speeded up the shutter speed by setting the ISO to 400 and the aperture was set to 8. ISO noise isn't as relevant for single image based reconstruction as it is for photogrammetry reconstruction. What matters the most are image details and consistency. To make sure that I cover the area, I set the focal length to 18 mm. I was trying to shoot with higher focal length, but I wasn't able to keep the camera high enough to cover designated area properly. As I mentioned, it is freaking hard to aim the camera this way, as I wasn't able to see any details on the screen. So I took a lot of photos just to make sure that at least one is useful as a source of data for reconstruction. A plaster is the next surface I captured. I found it on a weird building from 1965 in South Shields dockyard. Because the plaster surface I wanted to capture was on the ground level, this time I used a DSLR camera mounted on a tripod. I rotated the camera on side to get more vertical information, especially that I was planning to cut bottom part with grass. Next, I put two folded rulers next to the wall to help with framing and as a scale reference. At the bottom, I put the color checker. Since I used tripod for camera stabilization, I didn't have to worry about exposure time, so I set up the aperture to 11. I left ISO at 100 and I set the focal length simply to get proper framing, which was in this case 29 mm. And I took an image. A cliff wall is the subject of the next capture. Since I was looking for a surface which can be useful to build a seamless PBR environment texture, only the top part of this rock formation was regular and consistent enough. The bottom part of the cliff was too ruggish and eroded by water. Unfortunately, the only way to reach it was to use the drone. To compensate the depth of the surface and get sharp images, I set up the aperture to 4, and due to the strong wind I decided to leave the ISO on auto. Since there were no way to mount rulers and the color checker on a cliff wall, I captured the color checker held in my hand next to the rock formation, and I captured myself standing next to the cliff as an optional scale reference. Next, I flew up, picked a nice spot and took a picture. For the next capture, I have found an interesting place where old bumpy and irregular stone wall meets with the flat concrete. I decided to capture both with the DSLR camera mounted on a tripod. Since I was capturing from the ground level, I set up both rulers as a scale reference. I positioned the camera perpendicular to the surface and rotated it on side to cover area a bit higher to the ground. I set up the white balance, the focal length to 35 mm, aperture to 8 and ISO to 100, and I took the picture. Next, I moved both rulers to the concrete part. This time I also put a color checker at the bottom as a color reference. I didn't change any camera setting except the focal length to compensate the distance. I set it to 45 mm and I took another image. Next surface I captured was a tarmac. It was a sunny morning, but I found an empty car park with part of it hidden in a shadow. I defined the area with rulers and put a color checker next to them as a color reference, and I used the drone to capture the surface. I set the drone's camera aperture to 4, positioned the drone over the surface using rulers as guides, and when correctly framed, I took a picture. The last surface captured for this video was the surface of door's varnished wood. To capture it, I used the DSLR camera mounted on a tripod and cross-polarization technique to remove glare. This time I didn't use any rulers as a scale reference, and I set up the custom white balance before the capture. I also captured a color checker as color reference in case I need it for calibration, but I didn't. I set the camera's aperture to 8 and the focal length to 42mm and ISO to 100, and I took the image. And here we have all the images ready to proceed with the next step, which is an image tweaking with the photo editing software. For this I'm going to use Photolab 3. Since this technique is based on a single image only, we need to make sure that this image is as high quality as possible, as everything depends on it. Because all images I capture will capture in RAW format, any tweaking within the dynamic range we can consider as lossless. We need to make sure that before we proceed with the PBR reconstruction, any barrel distortions, vignetting and other color glitches are fixed and the color is accurate. To do this, we need to open each image in Photolab and apply every feature which brings clarity, consistency and improves image quality. So we need to set up the white balance by picking a neutral gray value from the color checker with the color picker selected. We should apply any noise reduction algorithm, lens sharpness, remove chromatic aberration, vignetting, fix barrel distortion, improve the contrast, tweak color distribution on histogram if needed, as any change and tweaks on this stage are processed on high density raw color data and can be considered as quality lossless. When done, we can export the result. I am exporting the result as 16-bit TIFF in case I need this level of color accuracy in the future. So far, Alchemist needs just 8 bits. When done, I repeat tweaks for other images. Because I didn't include a color checker for the rock image, I'm going to use one I captured separately. It can be done by selecting the image with the color checker as a first one and selecting the other one with the rock with Ctrl pressed to add it to selection. From now on, all tweaks will be applied to both images. But since we need just the one with the rock, let's export just this one. The same thing applies to the images with the concrete wall and the stone wall. As both images were captured in the same lighting conditions and just the one with the concrete wall has the color checker included, I'm going to use it to calibrate the white balance for both. And same with the varnished wood. I will apply the white balance using neutral clip captured separately. When done, we should have a set of images ready for actual single image based PBR reconstruction. To proceed with the reconstruction, let's import all those images into Substance Alchemist and turn them into fully procedural seamless PBR materials. The steps to follow are: import calibrated image into the Alchemist, apply bitmap to material filter to generate set of PBR maps and tweak them all until we are happy with the PBR result, apply a crop filter to crop the area we want to turn into a final PBR material, apply an equalizer filter to bring cross-surface consistency, apply the tiling filter to auto-remove seams and tile the texture in each direction, apply the clone patch filter to fix glitches if there are any and to rearrange parts of the final material if needed. And finally, we can apply a delighter filter, which should remove light information from the albedo map. Since applying filters isn't destructive to the data, we can tweak and modify any of them anytime, reshift them, and even remove until we are happy with the final result. So let's begin with the first material. First, let's switch the Substance Alchemist into Create mode and drag and drop the first image into the viewport. This is the image of concrete surface captured from the naval gun. Next, let's pick Use as Bitmap and hit the OK button. We won't see anything on 3D Preview Sphere until we apply the Bitmap to Material filter to the imported image. This filter, when applied, generates full set of PBR textures from the image. Now we can see the material preview defined by default bitmap to material setting. Let's set the real size and real height of the source surface we are trying to reconstruct. The size is straightforward as I unfolded the rulers to mark 180 by 180 cm large area. Since the concrete surface is almost flat, let's set the height to 0.5. We can change the preview mesh into something a bit more flat, like a rounded cube for example. This way we can easier preview the height map, but also material seams. To get better readability of light response, we can rotate the light around with Shift and right mouse button pressed. Depending on the light information from the input image, we can choose the height generation method. By default, it is set as luminance based, what turns all dark spots into concaves and interprets all bright as convex parts. This is why black frame of this color checker looks deeper, while color clips pops out. The luminance based method works for surfaces without any clear direct light, but since in this mode everything what is bright is considered as convex and everything what is dark is considered as a concave, it won't work for each type of surface as it generates false information. In result, dark rock on bright surface will be reconstructed as something deeper to the surface, even if in reality it pops out from it. The slope-based mode is made for surfaces which contains any direct light. The more direct light the surface has, the most useful this mode is. We can also mix both modes and set up the balance with the slider. Since the captured surface contains a bit of direct light, I will use the mixed version and push the slider until I'm happy with the result. With the high detail scale sliders, we can prioritize large, medium or small details. This way we can bring more small details and flatten big. When we are happy with the initial result, we can move to the next step and crop the area we want to become a texture. To crop square area without rulers, we need to use the crop filter. To preview cropping properly, we need to switch channel preview to scan 1 and set up the real resolution of the image. Next, we need to mark the area we want to turn into final material. Since I want it to represent 180 by 180 centimeters, I used rulers as a scale reference. And since I want the final texture to be square, to avoid any stretching, we need to hit the Make Square button on the top. When hit, any selection turns to be perfect square. We can preview tiling by hitting a letter T. All channels except the height and albedo seems to look correct. The height channel has terrible gradient and there is no way it can tile easily later. Also, the base color has some very evident cross-surface gradient and one side of the texture looks very different to the another one. To remove gradients and bring a bit more surface consistency, we need to apply an equalizer filter and equalize each channel until they are consistent. Just bear in mind it is not seam removal stage yet and we should focus just on overall surface consistency, not the surface details. But what we do now is going to help a lot on seam removal stage. Because I don't want to flatten everything, I apply detailed equalization just to certain channels. In this case, since the surface should be flat, we can set the equalizing radius for the height map to really low value until gradient completely disappears. Most details for this type of surface should be driven by the normal map anyway. Let's do the same to the base color map. I don't really like the single stone as it brings too much attention. Especially the dirt in the middle of it was interpreted as a concave. Since it is on the edge of the texture, let's fix it by pushing the cropped area to have this thing outside of it. I think everything looks correct on the stage, so since we are happy with the result, we can finally tile the texture. To do this, let's bring Make It Tile Advanced filter and play with options until we don't have any seams visible. This filter generates weird glitches on each side, which we can remove by bringing a clone patch filter. This filter copies data from one area to another. With the Alt and left mouse button, we select the area to copy from and mark target area by simply painting on it with left mouse button pressed only. This tool can be used to remove any glitches or to rearrange the texture. We can preview tiling in 3D viewport by changing the tiling option. The last thing we can optionally apply is the Delighter filter. This is the filter which auto-removes the light information from the color texture. Basically, it removes shadows and highlights caused by direct light. I'm not a big fan of it since it affects the color and changes it a bit and has no any control available. It simply hits the albedo however it wants and we can accept it or not. We have no control over it at all and in my opinion would be great to have at least opacity slider for it. I think we did very well and we managed to get a really nice and useful PBR material in pretty reasonable amount of time. When done, we can export the final material in format and resolution which works for us. Next, let's repeat the process with the other images until we turn them all into PBR materials we can compare. As next one, let's bring the grass surface. This is a surface type which is very hard to reconstruct using other techniques. This is definitely the toughest surface to reconstruct using photogrammetry. Due to its complexity and organic nature, it is also very hard to mimic procedurally. I have found that the single image-based reconstruction approach with Alchemist works very well and gives very decent results. It is work to bring a bit more ambient occlusion for grass, so it won't look flat. It is a kind of hack, but so far I noticed this is the only way to give it a realistic look. Overall, I would keep the grass sharp and emphasize sharpness everywhere it is possible. This is the case where light information embedded into the color texture is very useful and the lighter would just flatten the result. Let's proceed with the next image, which is the leaves cover. This one is a really tricky one for single image based reconstruction due to a very high level of complexity with total lack of color surface consistency. This is the type of surface where every detail matters, but is so complex from luminance point of view that it is hard to define any rules for reconstruction without use of sophisticated AI-based algorithm. But let's give it a try. This is the surface I also scanned using photogrammetry, so we can compare it with the scan-based result later. I think this is a good example to show that the delighter needs a lot of work to be useful, as it can go really crazy with the results it delivers. This is everything I can do for this texture. I don't know how to remove the blobby melting feeling and bring sharpness this texture needs. In my opinion, it is the first fail in this series of textures. Let's grab the next image and try to turn it into an awesome PBR material. This one is a bit tricky regarding to its direction. This is the first one, which was captured vertically, and the first one where surface direction of the image really matters. Let's proceed with the standard reconstruction steps, but this time apply a crop rotation when we use the crop filter. This is another case where the lighting didn't work at all. Next, let's process the image of the rock surface. Looks like this is the first surface where the lighter did a decent job and can be kept with the final material. Still, lack of control for this filter where even simple opacity slider would be very useful, makes this filter hard to work with. Next, let's process a flat concrete wall. Same as before, this surface was captured vertically for better space usage and needs to be rotated during cropping. Since I had some weird height glitches, I moved the equalizer filter after the material was tiled. And let's bring the next one, a stone wall. Definitely hard to tile no matter what tool I use. Also, the color of materials used to build it is inconsistent and each part might be interpreted differently during reconstruction. The default bitmap to material setting did some decent job already, even if the top part of material was misinterpreted correctly. Let's crop it so we can stay away to this tricky from the color point of view part and try to bring some surface details. The reconstruction isn't bad, but it is not also very good. As I can see, there is no way to get the quality we can get from the real scan, and no matter what we do, it is going to be more or less, but always just something in between. But since it's just an experiment, let's move to the next material. The next one is a tarmac. It's a flat and predictable surface, but unfortunately a bit noisy in details. And finally, it's time to process the image with the varnished wood surface. This one was a really easy one. Looks like this way of reconstruction is made exactly for this type of surfaces. Now it's time to compare the results. Let's bring all materials I made to Marmoset Toolbag 3 and preview them all. I managed to capture and turn into seamless PBR materials using single image based reconstruction technique 9 different types of materials. It took me about a minute to capture a single surface, additional one to tweak the result in photoediting software, and about 15 minutes per image to turn it into PBR material using Alchemist. Some of these materials turned really good, some are decent, and some are total crap. There is no other tool I'm aware of which can deliver this level of PBR quality in such short amount of time. It definitely wins when our priority is in quantity, low cost and short production time. Unfortunately, single image based reconstruction, even if works great with predictable and consistent from color point of view types of surfaces, it really struggles with more complex data. The best surfaces to reconstruct were these with the consistent similar color and without any additional color variety. So for varnished wood or plaster wall, this technique is definitely an option to consider. But if the quality is our target and we deal with complex from the height and color point of view surfaces, I would recommend to pick different technique like photogrammetry or photometric stereo. If the surface is predictable and consistent, the reconstruction algorithm does the job pretty well and seems to be the best to all available on the market. Unfortunately, reconstructed height lacks of sharpness and results are blobby and noisy. Even after the update, the Alchemist is still a bit glitchy, lacks some features like histogram or improvements like better control over the lighter. Also, the seam removal filter needs to be improved as it delivers really old school quality and really struggles with complex surfaces. I think that manual tiling in Painter or tiling in Artomatics works way better. The reconstruction algorithm itself, even if does pretty decent job and is definitely one of the best I had opportunity to play with, definitely needs to be improved and I guess needs to get an AI involved to interpret the data correctly. A leaves cover material is a good example of surface with the level of complexity where Alchemist in existing shape totally fails. This surface is very complex from both the color and the height point of view. I have captured this exact leaves cover also for photogrammetry reconstruction to compare the results. To capture all details, I took 169 images. Next, I spent a few hours processing them to turn the result into fully functional PBR material. But as you can see, the difference in quality when both materials are compared together is just overwhelming. It shows that in this case, no matter what tweaks I do in Alchemist, the result cannot even compete with the quality of photogrammetry based material. So I think this technique is a good tool for surfaces which cannot be reconstructed easily using other techniques and where noise or small physical inaccuracy isn't a problem. I guess this technique would work great to generate PBR material of really large areas, something like a few 100 meters wide area of grass, meadow or even forest, something to be used for long distance vista props. Also, the varnished wood surface was a good example of well and fast reconstructed surface. So, the single image based reconstruction with the Alchemist is definitely an option to consider for certain types of surfaces, but for some, other options and techniques are better. I think it is really worth to know what we can expect using this technique, where it shines and where it struggles, as the knowledge gives us the opportunity to make an informed decision about choosing the right tool for the job. I hope what I presented in this video was helpful and informative for you. If you like it and want me to create and share even more content like this one, please leave the thumbs up, drop a comment and subscribe to my channel. Big thanks to those who did it already, and thanks for watching. See you next time. Bye!